Good afternoon, everyone, and welcome to today's webinar, Artificial Intelligence and Cyber Security, which will be delivered by Praveen Vakhe. So over to you, Praveen, who will take care you through the agenda.
All right. Thank you so much, Shanam, and it's indeed a pleasure to be speaking with our business partners as well as their end customers today. Just to introduce myself, my name is Praveen Joseph. I'm a cybersecurity consultant and a trainer. Today's topic is really interesting. We are going to be discussing artificial intelligence and trying to explore the role that this really exciting field can play within cybersecurity. Right. So thank you so much, Shannon, for setting the tone for today's session. And guys, like Shannon said, we're going to have a quick look at the agenda, and from there we'll get down into action. Right. The first thing that we will start with today is basically trying to understand what artificial intelligence is. This is what will be covered under section 1, which is the AI foundations. And from there, I'm going to, with you, explore certain implementations of artificial intelligence today, all right, in the real world, and where AI is actually touching our lives as we go about working around the technology fields, right? And in section 3 is where we are going to look at where cybersecurity and artificial intelligence cross paths with each other. It's really interesting to see that AI can actually be used for both cyber defense purposes as well as for perpetrating cybercrime and cyber attacks as well, right? So from there, we will come down into enterprise defense strategies, look at how organizations can improve their cybersecurity postures using artificial intelligence. Lastly, Shanam is going to give us an activities update, and further to this, we will open the floor to questions. Okay, guys, so let's get going. I'm really glad we got a huge crowd here with us for today's session. The topic itself is extremely interesting, and there is no doubt about this. So with this, let's get going into the AI foundations. Starting with what really is artificial intelligence. All right, now what you're seeing here on the slide is a simple representation of the process that we as human beings follow every day on a day-to-day basis when we have to perform an analysis of a situation and behave intelligently at the end of the day. Right, a simple, very high-level representation. Basically, our minds have been designed in a way that they refer continuously to our previous experiences as well as our memory, and process information at very fast rates. And based on our interceptions of, as well as our perceptions, basically, of our past experiences, as well as what our intuition tells us, when we are presented with a situation, we, based on our own human intelligence and our own human capacities, engage in what we call reasoning as well as judgment of the situation. Right? The output essentially is what we call intelligent behavior, and this is behavior of humans on a day-to-day basis. What has this got to do with artificial intelligence? Guys, this is really interesting because in the field of AI, what we are trying to do is achieve the same sort of behavior, but only that it is to be carried out by a computer. Right? The field of AI is not something which is very new. In fact, I do agree with you. There's been a lot of hype, a lot of reports and news reports coming out about how artificial intelligence is being embraced by companies A, B, and C, and how AI can actually replace even human beings in their positions or within their jobs, really. But to be honest, AI has been around since decades, if you look at it, and the term itself was coined way back in 1956 by Professor John McCarthy of Dartmouth University. Right, so the field has been in existence for quite some time, but if you look at it, the implementation of AI was not, it has never been done at the levels and the scales that we see today. And what are the reasons for this? Now, there are 3 primary reasons for AI receiving so much information, so much attention, as well as so many use cases and implementation today. What are these 3 primary reasons? The simple answer is they all relate to this beautiful field called big data. All right, guys. Now, when you look at artificial intelligence, let's take a step back and look at how we as humans perceive a situation and make judgments. Now, we have our senses, sight, sound, hearing, taste, etc., through which we continuously receive information. We continuously process this data, And then within the brain, we actually, mix and mash all of this information until we come out with what is known as reasoned and informed decision, leading to intelligent behavior. So we are continuously receiving data, processing data. And what this means is when you're trying to achieve the same thing in AI, we need data. We need a lot of data, and big data is essentially what helps us to actually achieve this. Now, in today's world, you will agree with me, from the moment that you wake up in the morning till you go to bed, we work with our phones on an almost 24/7 basis. Our phones are with us wherever we go. We are online, we are connected for a large part of the day. In fact, if you look at it, all right, every single action that we do with a phone, it leads to the creation of a log or any other data file. All right, so companies like Google, Facebook, etc., are continuously processing, continuously collecting as well as analyzing the data that we generate as end users on a day-to-day basis. And big data is a field of being able to actually collect, process, as well as make sense out of all this data. And with this data, essentially, we have large amounts of inputs for intelligent behavior to be achieved by artificial intelligence. So of late, we've had enormous developments in the field of big data. Starting with the ability to store massive amounts of data. Hadoop clusters is one of the most popular mechanisms for storage of massive amounts of data, terabytes and petabytes, if you will. Also, there has been a tremendous increase in the computational capability of processors today. So, in fact, many of the AI systems, they don't rely on the regular CPUs that you and I are familiar with. In fact, the CPUs on our computers, they have, what do they have? Probably 2 to 8 cores within them, and they can achieve certain, good enough speeds when it comes to processing power. However, with AI, we have what is known as a graphics processing unit, a GPU, and most AI systems rely on a GPU, which have as many as 2,500 cores. Right? So, and they rely on parallel processing parallel computation of processes, which leads to far greater performance levels than the regular CPUs that you and I are familiar with on our computers. All right, and in today's world, GPUs can be generated not very cost effectively, but at an affordable price. And the next interesting field in which there has been massive development is that of quantum computers. All right, the area of quantum computers has received a lot of development of late. And at a very, very basic level, guys, you and I are familiar with the concept of binary systems, right? In today's world, all computer systems are based on the concept that data can be represented as binary digits or bits, if you will. So that's either a 0 or a 1. And based on this very, very basic foundational representation is what almost all computational systems today are built. But with quantum computing, we are relying on the state of subatomic particles, wherein they have more than just two foundational states. All right, so we have subatomic particles which can have more than two states which can be used to effectively represent data. And this means a giant leap when it comes to the processing speed as well as the capability of computers itself. Now, for many years, quantum computers were highly theoretical and hypothetical, but now companies like Google and the like have actually started building quantum supercomputers. And this again is a massive boost essentially to the development of artificial intelligence. All right, the last important domain that has helped in the development of AI is that of data analytics. So we have tons and tons of data that we are all generating. We have the computational ability to process, to store this data, to process it, and make sense out of it. But then essentially, how do you make sense out of this? This is essentially where big data analytics comes into the picture, or data analytics itself, if you will. So we have new and really, really advanced models on statistical algorithms, which can actually process data, identify patterns that exist within the data, patterns which are really not easily evident to a simple human person who's looking at the data. There are also algorithms which can try to correlate events which are seemingly unrelated and lying on completely disparate data sources. Right? So all of this is a reality today, and this is essentially, these three areas essentially are what have given a significant boost to the development of AI. And guys, today you will not believe the ways in which AI touches upon our lives. Like just from the moment you check into your Facebook and look at your news feed, to a huge number of other examples, and we're going to look at these as we go around. We'll be looking at how your facial recognition is how AI plays a part in the recognition of your faces, from untagged photos on Facebook We're also going to take a look at how AI is being used in medical research and in diagnosis of diseases. So we have a really, really interesting lineup of slides, guys. I hope I've set the context really on what AI is at a very high level. Coming back, it is getting computers to mimic intelligent human behavior. And the three primary fields that have helped us to get here are all related to big data, essentially, which is big data storage, and then quantum computing and GPUs, essentially, which lead up to processing capacity of computers. And lastly, there is the developments in the area of big data analytics. All right, now guys, before we get down to the further slides, there was one important understanding that we need to achieve. What are the levels of artificial intelligence? How far have we come when it comes to implementation of AI? Okay, now there are three levels, and that's what you can see up on your slide here. Starting with narrow intelligence or weak AI, and then we go down to general intelligence, AGI, or strong AI as it is known. And lastly, there is what we call artificial super intelligence. Now, all AI implementations today, guys, are, whether fortunately or unfortunately, they all fall only within the first category, which is weak artificial intelligence. We are yet to achieve the more advanced levels of strong artificial intelligence and artificial super intelligence. So any AI system that you see today, they all fall within the area of weak AI. What is weak AI? Let us try to understand. All right, at a very high level, the definition is you give one specific task to a machine, it will do that effectively for you. So you give it the instructions, it will learn more about how to do this job well, but it will only do that job for you. So for example, you take the case of a self-driving car, a Tesla, it will drive well for you, but it will not think on your behalf. You will have to do the thinking part, but the car will do the driving bit for you. And similarly with the newsfeed that, and the algorithms that actually personalize your newsfeed on Facebook, for example, as you can see on this image here. These are essentially algorithms that do just that. They personalize your newsfeed based on your preferences that have been identified by Facebook based on your actions when you're on the website. The links that you click, the posts that you like, the kind of photos that you upload, the locations where you tag yourself. So your newsfeed is more personalized based on decisions that have been made by these algorithms. And these decisions pertain to your preferences. What is it that you like? What is it that you're most likely to be interested in purchasing, and things like that? All right, so this is essentially weak AI, and the job it does here is trying to personalize you. And this is something that we call social profiling, guys, just for your knowledge. The other example is every time you pull up your Android phone and then say, okay, Google, you're familiar with what happens next, right? You have the Google Assistant that throws itself up on the screen and says, hey, how can I be of assistance? Essentially, personal assistants, whether it's Siri or Google or Bixby on the Samsung platform, all of these personal assistants, their job is to gather as much information about you as possible. The places where you carry your phone, the time at which you sleep, the time at which you wake up, the food that you eat, if at all you're tracking your food on a food tracking app, and of course the apps that you download, the activities that you're most interested in, the games you play. Based on all of this information, there are algorithms essentially that try to get as much of a complete profile of you as possible. And this essentially is what these personal assistants do. They try to profile you, and they try to personalize and potentially monetize your experience on these platforms, whether it's Android or whether it's Apple, the iOS platforms for that matter. One more very, very advanced example of artificial intelligence, weak AI, is IBM Watson, as you can see up here on the slide. We're going to talk about Watson in further detail as we go around, but this is one of the most popular AI implementations that has ever been built out there. We'll talk about it in the next few slides, guys. All right, so like I said, all AI implementations so far are only weak AI. But when we go down to the more advanced levels, right, is where we have strong AI as well as super intelligence. What really are these? Strong AI is basically a machine which can think a little bit like a human. Now, when I told you earlier, when you have a self-driving car, it does not do the thinking on your behalf. It does essentially what it has been trained to do, which is drive. Now, let's take the example of two boxers in a ring, two human boxers for that matter. Now, when you've been pitted against your opponent, what you would be doing is not only would you be very, very familiar with the rules of the game when it comes to boxing, you would also try to scope in and out your opponent. You'll try to learn as much as you can about this opponent. What are his strengths? What are his or her weaknesses? Any injuries or weak points and things like that you can actually exploit and thereby maximize your chances of winning. Now, this is a typical approach that all humans are used to when it comes to a competition. When a machine is able to think like that, that is when we have artificial general intelligence or strong AI. All right, a machine that is able to think more about its opponents and is able to defeat it, whether it's a game of chess or Jeopardy, like in the case of IBM Watson. As like I said, we look at it as we go down in one of the next few slides. When it is actually able to think and strategize and thereby maximize its chances of achieving a specific purpose, that is when we have artificial strong intelligence. Now, in today's case, we are miles away from approaching this. We have machines that are really, really good at gathering data, at analyzing it, at building rules, and then based on these rules, they act. All right, they cannot work on intangible data. Like, for example, my friend is, he doesn't have very good stamina levels, for example, or things like that. So the machines that we have today have not really reached that level of advancement. Now, yet another feature that AGI or strong AI machines are capable of, theoretically, is what we call recursive self-improvement. What is this? Essentially, the concept here is one machine which has strong AI will be able to build another machine that is more intelligent than itself. All right, theoretically, this should be possible because AGI machines are capable of improving themselves. They observe their situation, the environment that they work in, they observe their performance and review it. They learn and improve their performance, and finally the output is, a greater levels of performance. And theoretically speaking, they should be able to make a machine which is stronger than themselves. Now, recursively, if this process continues over and over again, ideally within a specific timeline, we should have machines which are far more intelligent than humans. And guys, this is essentially what this timeline is trying to predict, a point in time where machines have greater intelligence than humans. And this point at which machines are more intelligent than us is what we call the singularity. All right. So when really will singularity be achieved, we don't know. But when we look at the data, like you see on this graph, you can make out that it is inevitable. Because as you see here, human intellect has been increasing only linearly with time, and that at a very, very slow pace. Machines, they started only way back in the 1950s, but their levels of intelligence has been increasing exponentially. So it's only a matter of time, a couple of decades, if not a couple of centuries, before which machines will be way more intelligent than humans. And this is the kind of future that we're looking at. In a post-singularity world, we really don't know how things are going to be, but it is looking at the data, it only seems to us that this is inevitable, it cannot be avoided. And that is the reason, technology thought leaders like Stephen Hawking as well as Elon Musk, they have expressed their skepticism and stated that they have been pretty vocal about the fact that we have to be cautious in terms of what such a future would hold for humanity as a whole. All right, now this is a subject that is way beyond our scope for discussion in this 1-hour webinar. But just for your knowledge, singularity and intelligence explosion amongst machines, these are inevitable, and we have to be prepared for this, either us or our future generations. All right, guys, but now before we get on to section 2, we needed to really set the record straight in terms of these really, really commonly confused terminologies: artificial intelligence, machine learning, and deep learning. Very often we come across people using AI and ML interchangeably and synonymously with each other. Unfortunately, this is not really the case. ML is not the same as AI. Rather, let's try to understand this in a better way, right? Artificial intelligence, we know that it is the science of getting computers to imitate or mimic intelligent behavior, just like how humans do it. Machine learning is a subset of artificial intelligence. It is not equal to AI. It is just one of the ways in which you can actually implement AI. All right. In machine learning, you have an algorithm that can review its performance. If you remember, we spoke about this in the previous section on artificial general intelligence. Algorithms that continuously collect data on how they perform. Based on this data, they will self-adjust automatically. So these are self-learning algorithms. All their actions do not have to be hard-coded into them in the form of, let's say, an if-then-else statement. Rather, these algorithms will look at how they have completed an action, and they'll try to learn really how they can improve this action and do it better. What is the meaning of better? What is the meaning of worse? These are things that humans will have to provide to these algorithms. That is really where the learning may be supervised or it may be unsupervised. So it's up to, if it's an unsupervised learning, of course, it's up to the algorithm to decide whether it is doing better or for worse, without human intervention, and really we can't predict how these things can work. So it is always better to have supervised learning for machine learning algorithms. All right. Deep learning is yet another subset of machine learning. It is one of the ways in which ML or self-learning algorithms can be implemented. And how this is done? It is based on what we call neural networks. Guys, I'm sure you've heard about neural networks. It is basically a computing model that tries to imitate the working of the human brain itself. Don't worry too much about it, because on the next section, we're going to start with an actual case and see how a neural network model can be used to solve a simple problem in a self-driving car. Let's get going down there. All right, guys. So we're coming down to section 2. How are we doing with time? I think we're okay. We're going on with AI implementations. And like I said, we're going to start with a simple case. How really is deep learning being exploited in a self-driving car? Guys, you're already familiar with the concepts of self-driving cars. I'm sure you've seen or even driven them probably, or been in them, been driven in them, ideally, truth be told. Tesla has become mainstream when it comes to self-driving cars, and we do see them very often on the streets here in Dubai. When it comes to a self-driving car, you will agree with me, the concept is really, really crucial when it comes to identification of road signs. All right, now we are familiar with road signs, and we know if you're familiar with driving, how we have to respond to these signs. Getting a car to do the same, like you can imagine, millions and millions of lines of code has to be developed in order to achieve the same result. And luckily for us, it actually has been done. Let us try to understand in a very, very basic way how such a case would be solved. All right, now the problem statement here is identifying a stop signal on the road. And when it comes up on the road, essentially differentiating it from other stop signals, and then triggering the corresponding action, which is essentially to hit the brakes and stop the car. All right, now how do you go about solving this problem? What are the entities that you have available to you? So you have a database within which you try to pump in as much data as possible to identify the stop sign. All right, so to identify a stop sign, you will have to have a list of all road signs, objects that look similar to the stop sign. So for representation purposes, we have built a database of the stop sign, the give way sign, the speed limit sign, as well as the no entry or do not enter sign. Next up, you should have a list of objects that look similar to the stop sign, but they're not the stop sign. They're not a road sign itself, for that matter. And thereby, we have obtained a list of a picture of a kite. A kite which looks red and has certain white lines as well on it. All right, now this is a database. This is your training data, essentially. And this database, please follow only column 1 over here. Let's not get on to the other remaining columns. This database is what you will seek to achieve with maximum comprehension, comprehensiveness as possible. And this database has to be fed into what we call as a complete training data set. When this is fed into a neural network, how the neural network approaches this is, it tries to identify what we call features present within the training data set. So what are these features? In this particular case, each entry here has a unique shape, as well as it has certain mixtures of colors. All right, I shouldn't be saying unique shape. It has a specific shape, and then it has certain specific colors that go into defining it. The neural network will automatically decide that, yes, shape is one of the factors on which I can differentiate these entries. Colors is yet another feature based on which I can differentiate the entries. So 2 features have been already identified by the neural network, which is the shape, which is octagonal for the stop sign, triangular for the give way sign, and circular, and so on and so forth. What are the colors that are present on them? And then there can be n number of other features as well, which uniquely can be used to uniquely identifying a specific road sign. All right, so just for representation purposes, we are going to follow only these 2 features, which is shape and colors. And then the neural network decides upon a label for each data entry. All right, so we have a label 1 for the stop sign, 2 for the give way sign, and so on and so forth. So from the database terminologies, this is essentially a primary key, which can be used to uniquely identify each entry. All right, now, so like you can see, in a very, very high level way, the algorithm is designed in such a way that it collects the data that it sees on the camera, and then it compares it with the database, the training data set that it already has. So when it sees a stop sign, it tries to match it with each of the entries over here. And then it says, hey, it has a shape which is octagonal, it has the colors which are R and W, red and white, and thereby it matches with the label which is stop. Hence, I see a stop sign over here and I have to hit the brakes. Right? So it's very, very simple, guys, when you look at it at a very foundational or basic level. But like you might have guessed, in the real world, it's far, far more complicated than this. This is just one way of achieving this purpose, but there are other models as well that can be done, that can be implemented. But in a neural network, essentially we have as many as just about dozens of nodes that are interconnected with each other. Whereas, but this can stretch for as many as thousands, hundreds of thousands of nodes. Yes, they are connected to each other, collecting and sharing data with each other, like you can see over here. They decide what are the features. They decide what are the labels that can be assigned, and they uniquely, try to categorize each piece of data or road sign in this particular example, and match it with the unique entry that they have in the training data set. And from this matching, they kick out the corresponding action, which is in this case, stop the car. All right. So with this understanding, guys, which I hope has been useful to you, we can draw a very, very foundational model of any AI system. All right. So this is what we see up here on the slide. Any AI that you see should have a sensor of which can be a microphone, it can be a camera, it can be any other signal detectors like heat detectors and things like that. And then we have the algorithm, which is essentially the brain of the entire model. And to for reference purposes, there should be a really, really well-developed training data set. Like I said, in the case of Tesla's self-driving cars, these cars, they share information with each other. All the cars on the road, they upload the recordings that they make every time they drive, every time they're on a drive. And this is available as a master data set that every Tesla car has access to. All right, so we have a really, really tremendously huge data set when it comes to self-driving cars. And the same concept applies to whether it is IBM Watson or whether it is Google Assistant on your mobile phones. All right, a large data set. So in the case of your mobile phones, this data set will have information about you. Really, what are your habits? And that is the reason your data is being collected in such a massive way. Based on this data set of habits is how your recommendations are made. Hey, we think you might like a restaurant here because you ate something, pieces of food A, B, and C from that restaurant in that city. Thereby, we think that now that you're in this city, you might like this restaurant and things like that. So these really, really complex decisions are made, and the recommendations are passed on to you simply based on the algorithms as well as the training data, right? So with this foundational model, let's look at some very, very popular AI implementations, starting with IBM Watson. Guys, I promised you that we'll be looking at Watson in further detail as we go on, and now's the time to do this. At a very high level, guys, Watson is a very, very advanced question answering machine. All right, it's been developed by IBM, of course, and it's been around for quite some time, close to a decade, in fact, for that matter. And it is really advanced and ahead of the competition in many ways. The reason Watson fought into limelight was when it was able to defeat human players and really, really expert players at a game of Jeopardy. All right, on a US TV show, and this really shot it into the limelight. Since then, IBM has been exploring how they can actually use Watson for more advanced purposes. How does Watson work really? You feed data into it. Now, when I say feed data, this is where your sensor comes in. You can speak to it. You can ask it questions in natural English or any other language, and Watson has one of the best natural language processing capabilities in across AI implementations today. So when you speak to it, Watson will interpret the question, and then it refers to its massive training data set. Now, I don't know personally how big the training data set is and what sorts of web pages or directories that Watson has access to. But I do know that when it defeated these people at the game of Jeopardy, it had access to the whole of Wikipedia and more than 200 million web pages. Right. So this was quite some time back. As of now, the latest figures it's probably internal, but we don't know really what levels of data or web pages Watson has access to. So when you ask a question to it, when you put it forth to Watson, essentially it interprets the question based on the algorithms that have been coded into it, and then refers to the training data set, and then it gives you the output. The area where Watson really brings in efficiency is over a human person is the speed at which it is able to find the answer for you. The speed at which it is able to analyze millions and millions of web pages, find out the answers, and then present them to you. Right now, this speed is crucial because there is a massive level of accuracy as well as efficiency involved. And this is crucial for the medical industry because when you feed it with a list of symptoms, it is able to diagnose what really could be the most likely cause. It can also be used for legal counsel, wherein it can skim through millions and millions of pages of legalese or legal text and thereby come up with the best recommended approach, whether you're a plaintiff or a defendant. Financial advisories as well as IoT solutions as well. That's another area where IBM is pushing Watson across sectors in automotives, electronics, etc. And an interesting thing, guys, about Watson that I failed to mention, it doesn't just process your speech. You can also feed reports into it, whether these are complex charts, tables, unformatted data, or even image files, and it would still be able to make sense out of it and structure it into a proper usable format. The next example of AI, and a very popular one at that, is Alexa. Alexa is Amazon's answer to the AI problems of the world today. And Alexa is nothing but a very, very sophisticated personal assistant, right? So it is very comparable to your Siri as well as your Google Assistant, except that to use Alexa, you don't really need a mobile phone. You don't just need a mobile phone. Rather, you'll have to purchase one of Amazon's Echo products. They come in as speakers, like you can see up here. And there's a whole suite of products like Echo Dot and Echo Show and things like that. But you'll have to purchase these. And the idea is you can actually speak to the speaker. And there are about 8 microphones on this particular product that are, arranged in a circular fashion. So the concept is that you can place it somewhere inside your living room, and wherever you are around the device, you can speak to it and ask to it certain general questions like, hey, Alexa, how's the weather today? Or what's the quickest route to my office, and things like that. The idea is that Alexa has access to a massive training data set again, and it will process your questions, although they haven't posed in natural language, and try to give you the best answer in the shortest possible time, the most accurate answer in the best time possible. All right, where else Alexa can add value is it can be integrated with the smart devices in your house. So if you have, smart lights or cameras, CCTV cameras with IP addresses, these can also be integrated with Alexa, and you can actually ask it to, hey, turn on the lights and phone, adjust the temperatures, show me what's happening on camera, CCTV 1, and things like that, right? So that integration with your other devices is also possible, but the concept, like you can see, is the same. And let me remind you again, this is just an implementation of weak AI. We have a device, like you can see, you have a device that understands your questions and then presents the answers to you in the best way format, and in the best format possible. Okay, great. The next example is that of Facebook's facial recognition. Now, this is really, really interesting, guys. Now, I remember back in the early days when we were on Facebook, if there was a photo of yourself that was uploaded, you were okay as long as you were not tagged in these photos, right? So you were comfortable with the fact that, hey, I've not been tagged, so it's okay, and things like that. Guess what? This has changed, and it's changed since quite some time, because Facebook has made significant investments, millions and millions of dollars, 55 million, I think, into artificial intelligence, acquiring a firm as well as developing its own capability around AI. And these AI technologies, primarily the idea is to help Facebook make sense out of the 300 million photos that are being uploaded to it on a daily basis. 300 million photos, of most of them of people, being uploaded every day on Facebook. How can Facebook make use of this database to uniquely identify a person? That is where face identification comes into the picture. Face recognition as well as identification. So essentially what happens is when you upload a photo on Facebook, the pixels that represent your face, these get categorized into a unique string of numbers, and that is what we call a template, or like Facebook calls a template. So each face is given a unique ID, which is essentially the template. And every time a photo of yours is uploaded, Facebook detects the faces on this particular image by analyzing the pixels. It matches the template IDs of these faces with its existing data set, which is where the training database comes in. It matches this with its existing data set of templates that represent unique individuals' faces. And where there is a match, that's where your output comes out. The possibilities are endless, guys, if you think about it. So imagine you are an organization and people are willfully uploading their images onto your site. You are able to uniquely identify them, all right, and across their day-to-day lives. So, for example, I have uploaded a photo of me at a restaurant in, let's say, city ABC, and I'm eating food which is XYZ. Now, Facebook is able to make sense out of this photo that, hey, I'm looking happy in this photo, which means I probably like the food that I'm eating, as well as also possibly I like the city that I'm at, or I like the restaurant that I'm at. Based on this, Facebook can actually make some personalized ads for me, personalized ads that pertain to the food that I'm eating or the restaurant that I'm visiting, things like that. Yet another more user specific feature is that of notification to the user. if their photos have been uploaded and they have not been tagged. All right, so think about a scenario where someone has uploaded a photo which has you in it, your face very clearly represented in it, but you've not been tagged. There's no way you would know about it unless by chance you came to see this picture across on your newsfeed. But Facebook has this beautiful feature wherein they have detected your face on this image, and they have sent you a notification saying, hey, take a look at this picture. We think it's you, but we see that you're not been tagged in it. So maybe you want to take a look, and if you want, you can request the uploader to take the picture down and things like that. So this is a more user-friendly feature and something that is more privacy-oriented, if you ask me. All right. The other area where we see it being used almost on a day-to-day basis is when we upload photos on Facebook and the tag suggestions automatically throw up. The question is this Mr. XYZ, is that Miss ABC and things like that. I'm sure you are familiar with this. This is definitely facial recognition at play, whether you realize it or not. And there's a lot of AI algorithms that go into this, guys. Perfect. Now we are coming down to the core concept where AI can be used for cybersecurity. All right. Like I said, AI can be used for both good as well as bad purposes when it comes to cybersecurity. Let's take an example of a good purpose where AI can be used for cyber defense. All right. And I'm going to look at the example of risk management. And what you see up on the slide here is, don't let all these images confuse you. Just stay with me as I walk you through it. What we're going to do is, with a traditional approach, that is a human-based risk assessment. What are the steps involved in a risk assessment? And then we're going to look at how an AI-powered system can actually help or add value to the manual process of risk assessment. All right. Now, primarily, there are three large phases that I have decided to represent over here. Bear in mind that risk assessment is something that can be carried out in multiple methodologies, ISO 27005, Octave, and ISTSP 830. There are many methodologies out there. We are just using a very high-level representative model out here. And in this model, like you can see, we start with data gathering, wherein you try to define the scope of your risk assessment. What are the boundaries? What are the organizations to be scoped in? What are the buildings to be added? What are the teams? What are the processes, business processes, whether it's finance, HR, production, data center, IT ops, whatever it is, we add them all over here. Within these scoped environments, what are the assets that exist? What are the values of the asset? What are the owners of the asset and things like that? And then from there, we try to identify the vulnerabilities, and we also try to estimate the threats. This is essentially where step 2 comes in. We do controls testing to see how well a control is performing, where it is likely to fail, and then what are the threats that can exploit these vulnerabilities, for example, when the control fails itself. And to do this, we rely upon our experience as well as our judgment. All right, I'll take you back to the first slide where we saw how human beings make decisions that lead to intelligent behavior. Primarily, we rely upon our memory as well as our personal experiences or experiences of those near and dear to us. All right, and then lastly, we come out to the calculations. There are multiple methodologies, quantitative or qualitative, as the case may be. Our final risk response would be to either accept the risk or treat it or transfer, or maybe even to just avoid the whole risk-causing activity itself. When it comes to AI, guys, you can make sense out of the slides that we ran over just now. The AI primarily can help us with gathering of multiple data, so gathering of data from multiple sources, making sense out of this data, and then giving us information or giving us hidden threats, hidden vulnerabilities that were definitely not evident to us during the human review. All right, so an AI-powered system would, like for example, in the case of Watson, like we saw, it would be able to process data from multiple reports, multiple tabular columns, charts, whatever it is. It really doesn't matter. And then it would be able to bring the data up into a consistent, usable format with up to the mark levels of data quality. And even if there is a change in the data with time, these updates can also be automatically fed into the system. There is no need for us to go back manually and then update this. So if there is a change in the list of assets or the ownership of the assets, or there's a change in the scope of the organizations, that has to be brought into the risk assessment. Like for example, a new business process has been built, or a company has been acquired, and things like that. These updates can be automatically consumed or added by the AI system itself. And from this data, the AI system, based on big data analytics, like we saw earlier, it will be able to identify threats, correlate events, capture hidden patterns that are not easily visible to the human eye. And then from there, it will help us in the final step, which is calculations and what are the risks to be taken. So it'll give us a recommendation, and also these recommendations would be accompanied with a confidence factor, a confidence weightage that indicates really how confident the AI system is of the recommendations accuracy. All right, now with this information, we will be able to make informed decisions and far, far better and more efficient risk assessments. Okay, now let's come down to the other side of the table, which is cyber crime. Yes, I'm sure you've seen reports about cyber criminals exploiting AI techniques for perpetrating their criminal activities. And yes, most of it is true. At least those who have access to AI systems, who have the knowledge as well as the funds, they have started using them. Let's take a simple example of the case of phishing and see how AI can actually help these criminals to massively upscale their activities. Okay. Now, when it comes to phishing as well, there are three primary phases that we are trying to represent here. Just for information, pure phishing is a subset of phishing, wherein you have a specific target and then you try to craft a phishing mail that is personalized for the specific target. So let's take a traditional approach wherein a human being is trying to phish a specific chosen target. So the attacker would essentially try to gather as much data about this individual as possible, check out his or her LinkedIn profiles, Facebook, and any other social media platforms that they are on. Maybe even try to get some other insider information by making social engineering calls, and then try to understand more about this individual. What are his or her likes, dislikes, preferences, and things like that. And from there, try to draft a mail or a tweet, like in this particular case. And that is very, very relevant to this individual. Can also be contextual if possible. Like, for example, hey, this is in relation to your recent purchase for package XYZ from Amazon or some other site like that. Right? It can also it also has to be compelling. So the user is intrigued to click on whatever link is present within the phish, or downloads the file or whatever it is that might be available as an attachment if it's a phishing email, right? And then lastly, you should be able to send the email, or like I said, in this case, it's a tweet. You'll have to send it out to the individual. How many such personalized targeted mails would you be able to send within a minute? Guys, there was a company called ZeroFox which actually carried a test wherein a human being was tasked with drafting, phishing tweets targeted at specific individuals. The best this particular person was able to do was he was able to send out 1.75 targeted phishing tweets every minute. All right, and in comparison, they had an AI system as well, which was coded to achieve the same activity. And this system carried out the task in a far, far better way. It was able to perform this activity called timeline scraping, which is exactly what it sounds like. It was able to scan the target's Facebook as well as Twitter feeds and try to make informed decisions about what his preferences are. And then it was able to craft a very, very personalized tweet. And it was able to do this 6.75 times every minute, right? So it had 6.75 unique tweets that were shot out every minute. Far greater efficiency as well as accuracy when compared with a human being. So if a cyber criminal has the knowledge as well as the funds to invest in an AI system and thereby power his or her cyber attacks, then yes, we have a future which is not going to be as good as it is when it comes to the world of cybersecurity. A lot more attacks that we can expect, and increasing levels of complexity as well as efficiency. All right, guys, there are also privacy implications when it comes to artificial intelligence, and how do organizations address this? Now there are two specific examples that I want to talk about, guys, when it comes to data privacy. And you will agree with me, privacy is not something which is very separate from security itself. These two fields have to work hand in hand in tandem with each other. And I've taken the example of GDPR over here because the time could not be more relevant than right now to discuss GDPR. Like you might be knowing, General Data Protection Regulation. This is a new regulation that is focused on protection of privacy of EU individuals, European Union individuals, and it applies to organizations across the world, wherever you're located in, as long as you are processing data that belongs to EU individuals. It doesn't matter where you're located, GDPR will still apply to you. All right, so these requirements will be significant to you. And the scary part is we don't have much time left because GDPR comes into effect on May 2018 itself. So just about 3 months left, guys. And organizations across the world are grappling to understand the requirements and catch up with GDPR. The reason they are worried is because of the fines, which can be as high as 20 million euro. Yeah, that's right, 20 million euro. Okay, so let's take a simple example of what GDPR brings in the area of artificial intelligence. Now, there are two specific areas that I wanted to highlight. The first one being the facial recognition case that we saw on Facebook itself. All right, now in this particular scenario, what we saw was Facebook is assigning a unique template for your face based on your based on the photo that has been uploaded on Facebook, and this template is used to uniquely identify you as a person. Right? With GDPR, there is something called sensitive personal data, which is considered to be more secure, more critical, right, than just personal data, and biometric data falls under this category. Now, generally, GDPR is not very concerned about photos that contain your faces, but if these photos are being used to uniquely identify you, then yes, it is considered to be biometric data. All right, so yes, in this particular case of Facebook, since the photos are being tagged to you and used to uniquely identify you, they definitely fall in the category of biometric data, and thereby it is sensitive personal data under Facebook. All right, now in Article 9 of GDPR, you cannot process any sensitive personal data unless you abide with one of the many exceptions that has been provided by GDPR. And the one that is most relevant to Facebook is acquiring explicit consent of the data subject. So Facebook can no longer, essentially what this means is Facebook can no longer process your facial information or data that pertains to you and use it to uniquely identify you unless it has obtained your explicit consent. Bear in mind, this applies only to EU individuals, guys. So you have to be an EU citizen or an EU resident in order for this to apply to you. So if this is the case, yes, you can expect Facebook to start rolling out a message that seeks your explicit consent for using photos to uniquely identify you. All right, so when I say explicit consent, what I mean is you will have to actively agree to it, which means you'll have to check a tick mark and a checkbox, and then click on an OK button and say, yes, I am okay with Facebook using this information. All right, so these are all specific terms under GDPR, explicit consent, the definition of biometric data and things like that. But this is a significant implication for Facebook because many users might not even agree to this without understanding it properly. Another implication is we saw cases of medical diagnosis being made by technologies like IBM Watson. We saw cases of legal advice as well being provided, right? Now, these are cases where data about an individual is being processed by a machine, and then decisions are being taken, and then recommendations are made based on these decisions, all right? Now, GDPR has brought a requirement that says you as an individual, an EU individual or an EU citizen, you have a right not to be subjected to such decisions when they are being completely automated. All right. So what this means is, as an EU individual or an EU resident, you have a right to request that a human being also be brought into the decision-making process. So, for example, when it comes to medical diagnosis, I can ask that, hey, Watson has prescribed that I am suffering from disease ABC, but I still want a medical practitioner, a human, to come into the picture and verify this claim. Well, now that's a more not so worrying situation because in almost any medical scenario, you will have doctors verifying the opinions that have been made by robots, right? But then think about other more, less sinister cases, for example, like online credit applications or e-recruitment. These are not met. The individual has a right to contest this. All right, he has a right to request that a human being be brought into the picture, and he or she will clearly specify whether this decision that was made is correct or not. Okay. Perfect, guys. Go down to the next slide. All right, guys. So now we're going to look at how organizations can use artificial intelligence for improving their own cybersecurity postures. All right. The very, very first and foundational element, of course, is human beings. Like we understood, like we already understand, any cybersecurity implementation is only as effective as the weakest link present within the enterprise itself. And that, of course, is human beings. Trainings is the best way to get to this particular issue. And we from Ingram Micro have a whole suite of cybersecurity trainings which touch upon the risks presented by AI systems as well. I'll talk about this on the next few slides. From the operations side, yes, although the attacks powered by AI, like we saw in the case of phishing, although these attacks may seem far more sophisticated and far more complex, the vulnerabilities that these attacks target, they still remain the same. All right, so the machines that they target are those which have not been patched, or those where anti-malware solutions have not been updated, and those that are not working as intended. Right, so the foundations really still remain the same, guys. So the importance of security operations and maintaining them on an ongoing basis has never been more crucial or vital as it is today. The scope of attacks has increased massively, and AI is only adding fuel to this particular fire when it comes to cyber criminals using it. And yes, of course, it can also be used by organizations for defense purposes as well, like we saw in the earlier section of risk management. But let me reiterate here, the foundations still remain the same. Anti-malware solutions, maintaining and patching and maintaining and updating them on a day-to-day basis, patch management solutions, all of these still remain as important as they have always been. Data backup solutions are also crucial to us, especially in the face of ransomware attacks. I don't need to reiterate this. And lastly, in the area of monitoring, deep learning SOCs, right? This is Security Operations Center. This is something that enterprises across the world are looking at, and I'm happy to let you know that McAfee has actually made some significant strides in this. A new tool from McAfee called Investigator has just been launched a couple of months ago. And this is a deep learning application that tries to learn as much as possible about the threat environment of an organization and present meaningful data to the security analyst sitting in front of the screen, data that can help him or her to make informed decisions about the threat environment that the organization is working within. All right, guys, a quick look at the cybersecurity portfolio that we have from Ingram Micro. We looked at the technology solutions just on the previous slide, but like I said, these have to be supported or complemented by cybersecurity services and trainings as well. Trainings is what we discussed just a few minutes ago, the importance of getting the most weakest element of any information system trained and up to the mark. And this is where we bring in a whole suite of cybersecurity trainings. We have the foundational trainings for those who are not familiar with security concepts, all the way up to very, very specialized trainings and certification trainings. GDPR that we spoke on, we just launched a series of GDPR specific trainings, which are called CIPP/Euro, Certified Information Privacy Professional, as well as Certified Information Privacy Manager. And these are brought to you by the International Association of Privacy Professionals. This is the most eminent organization when it comes to privacy professionals, and CIPPE and CIPM, these are considered to be, or these have been stated to be the most relevant certifications for a data protection officer to hold. A DPO is one of the requirements of GDPR. Organizations are required to hire a DPO, and these are the two most relevant certifications for a DPO to have. From the services side, yes, our technical assessment services, consultancy, as well as managed security services always remain at your disposal. We have consultancy services like risk assessments, gap assessments, audits, policy and procedure review, data classification. All of this are activities that we are more than happy to work with you to deliver. So if you have an end customer who is having a problem in terms of ISO 27001 compliance, or needs to get their organization up to the mark when it comes to PCI DSS or any other security standard for that matter, we have a team of qualified and highly experienced consultants, guys. I'll show you the team members in just a few slides. And we are more than happy to work with you to address these problems for your end customers. And we have experience from across sectors, whether it's banking or hospitals or insurance or any of these sectors. The team has got strong experience from working across all of these sectors. Perfect. With this, guys, I'm going to hand it over to Shanam for the activities update. And thank you so much for your attention. If you have any questions, feel free to put them out to me. My email ID is also going to be thrown up in just a few slides. Over to you, Shanam. Thank you so much.
Thank you, Praveen. Hi, guys. Hopefully by now, you are all aware of the cybersecurity website is live now, and you can explore it at security.ingrammicro.com. Please subscribe to our YouTube channel, Ingram Micro Cyber Security, where you can rewatch this webinar and other previous webinars and more. Get social and interact with us. Follow our Twitter account at IM Cybersecurity, and tweet us any questions you might have. This February newsletter will be sent on 20th February. Please keep an eye out for it, and if it appears in junk, remember to whitelist it so we can receive it straight to your inbox. We have some exciting updates to share with you this month. We're also holding a Palo Alto webinar on the 25th of February at 3 p.m. Securely enabling public and private clouds. Please register here. The link has just been shared in the comment section. Also, FishMe webinar are also be conducting on a technical training day at the Ingram Micro offices on 26th February. We'll be sharing a lot of insights into FishMe software and providing lunch. We hope you're able to attend. The registration link has also been shared in the comment sessions. If you have not already used your 2 free PDRs for end customers, please get in touch and we'll be happy to get this arranged for you. Okay, the 7th Annual Cloud Summit 2018 is the largest global cloud technology conference where value-added resellers, telecommunications and hosting professional developers, managed service providers, independent software vendors, and leading technology manufacturers come together for 3 days to learn, network, create new opportunities, and walk away inspired. It will be held in Florida, and the registration link also has been shared in the comment sessions. Okay, now this is our vendor portfolio. We are now the official distributor of SonicWall in Saudi Arabia and Egypt. We are also the official distributor of Quest in GCC, Saudi Arabia, Egypt, Levant, and North Africa. Also, the official distributor of Simplicity across Meta in GCC, Saudi Arabia, Egypt, Levant, and Turkey, Pakistan, South Africa, and Morocco as well. Ingram Micro has also introduced a business unit dedicated to Internet of Things as well. All right, thank you for attending, everybody, the webinar. And if you have any questions, please let us know, and Praveen will be happy to assist.
Thank you so much, Shanam. And guys, like I promised, here's a list of the team members with our email IDs as well up on your screen. If you have any questions, feel free to type them out to us. You can also type into the comment section. That's totally fine. We'll be more than happy to get back to you with the answers. In the meantime, let me take a second to thank you again for your attention. It's been great having you, and we hope the session was useful. And that's it, guys, from us. Thank you so much. Thank you, Shanam.
Thank you. Thank you, guys.